Welcome to part 2 on my series on how to build a temperature-controlled solar collector fan. A few things have happened since the last video. My hair has grown. A bunch of new electronic components arrived in the mail, so now I can actually make this video. And I've made, since then, a few changes to sort of the power supply portion that we talked about in the last video. So that's what I'm going to cover in this video is the changes, and I'm going to show you what I've done with the perf board prototype, and then we'll wrap up this video, and the next video we'll go into building the electronics for the fan control as well as the software that runs on the microcontroller. And that will be it. So that's just this video and the next video. So let's get into it. Okay, so here we are looking at a schematic of pretty much where we started off last time. I've drawn everything on graph paper now, and we have the 12 volts, we've got our L through and 7, and the first change we see here is instead of a voltage division circuit with 2 resistors, I've replaced that with, actually this is a 2K adjustment potentiometer. It was much easier to dial in the exact voltage using a trim pot instead of trying to do math and figure out the 2 resistor values. That stays the same. And one thing I should have done that I didn't do on the last video was add the decoupling capacitors to the prototype breadboard. There was a friend of mine that commented on the last video and pointed out that I had forgotten these, and indeed I did. So anyway, just pointing that out. Now, this circuit right here, this is new. We didn't have this in the last video. Basically what this circuit is trying to accomplish, it's called a brownout reset circuit. Essentially what happens is, on the reset pin, we're going to hold the reset pin low until a certain voltage is reached, at which point we'll allow the reset pin to go high like normal, and our program can run. When the voltage drops below a certain level, it'll pull reset to ground, or pull it low, and our chip will no longer be able to run our software. And this will, in effect, fix some of the wonkiness that can occur when the voltage is just high enough to allow everything to run, but not enough to allow it to run correctly. So at the heart of this circuit is the 2N3906 PNP bipolar junction transistor. And this, a PNP bipolar junction transistor is considered on, if you will, when the base is pulled to ground. And the way we're establishing a voltage threshold is with a 2.4 volt Zener diode configured in the reverse bias. So when the voltage reaches above 2.4 volts, or before it does, not much current is passing through here. We've got, a 1 megohm to ground over here. We've got our 1K flowing through the bipolar junction transistor and stopping at our Zener diode. And of course we've got a 10K resistor pulled directly from our power source. And once that reaches the 2.4 volt threshold, current is then allowed to flow through the Zener diode, pulling this to ground and is turning this transistor on. Now when that happens, whatever voltage is on this line is now also on the reset line. When that is not the case, reset is pulled to ground with this 1 megohm resistor. And once we've turned the reset pin on, we're also just gonna turn on a little red LED indicating that our program is now running. And 3 volts is of course applied to the rest of the circuit just as normal. So let's take a look at our prototype. Alright, so here's our prototype, and the first thing you'll probably notice is instead of having our resistors that were creating our voltage division circuit, we now have a 2K adjustment potentiometer, as well as we've got our decoupling capacitors. Both of them are 100 microfarads. And just as before, we've got our input voltage, which is 12, and then our output voltage, which is 3. Now, just to demonstrate for a second this adjustment potentiometer, I've got my meter hooked up to the output. This rail is the output of this voltage regulator. And basically what I'm going to do is I'm just going to turn the pot clockwise. And you can see the voltage rising there. And then if I turn it counterclockwise, I can get it back down to my target voltage, which is 3. And there we go. And that is as easy as it gets, right? Okay, now what we're going to look at is our power or our brownout reset circuit. Now here is our 2N3906 bipolar junction transistor, and here is this is an EBC transistor, so we got emitter collector base, or emitter base collector. And what I'm going to do here is I'm going to read the voltage off of the emitter. I'm trying to look through the camera and do this at the same time. And there it is, 3.064 volts. And that is going to adjust the reset pin. Now on the power supply, what I'm going to do, actually what I should do, is I'm gonna read the voltage on our line, or on our output here. Whoops. Gotta get everything hooked up just right. There we go. So you can see both voltages now. I'm going to drop this to, let's just drop this down to say 1.5 volts on this meter. Now in theory, what should happen is our reset line should be pulled low. So we should be reading 0 volts on that, and indeed we are. So basically what we've done here is we've told the microcontroller to be in the reset mode when the voltage is below 2.4 volts. Alright, so here's a first look at what's going to be the final product. It's basically just a perf board layout. So I've got our voltage source coming in here, got our decoupling capacitors, got our LM317, which has heat shrink around it for electrical isolation, because this top part is actually conductive and does affect the output voltage. We've got our trim pot and our brownout reset circuit right here. So let's go ahead and fire this thing up, see if it works, right? There we go. So we've got our power LED. Let's go ahead and see if we can read a voltage. Output voltage here. Hook that up like that. There we go. And we are reading 2.02 volts. So what we can do is we can just dial that up here, our trim pot, to our target voltage, which is 3. All right. Just turning clockwise. Almost there. And there we go. 3 volts. So that's it. That pretty much concludes this video. We've got a pretty effective power supply here. We've got, we're stepping down any voltage between, roughly 4 all the way up to 24 volts down to our 3 volts. And just in case it dips below that, we're protecting ourselves by telling the microcontroller to be in the reset mode when there's not enough power to run it correctly. So next video, we're going to talk about the electronics to drive the fans, which are going to be connected over here, and as well as the software that runs this whole thing. So see you in the next video.